You're probably used to autoregressive AI language models that generate text from left to right by predicting the next token, but you may not have heard of diffusion language models that start with total chaos, generates multiple sentences in parallel, and then just keeps iterating on the statement and changing it until suddenly there's a whole paragraph there. Mercury by Inception Labs is the latest diffusion language model. It's closed source and it's commercial. Even though my channel is usually about open source, I still wanted to point this one out just because the technology is interesting. You can see in the upper right corner of the browser, it lets me turn the diffusion effect on, so I've done that so you can see an example of what it looks like. You can see how it sort of just went through different iterations of the text before it landed on the final one. There is an experimental research-based open source diffusion language model that's an 8 billion parameter instruct model called LLaDA. I'm not really sure how to pronounce that, but they also have a Hugging Face space that allows you to test it. So let's see what we get there, because it says that it'll show the diffusion denoising process on the right side. This system works similarly to image diffusion, where it starts off with a noise canvas and gradually iterates over that through multiple passes until the image gradually comes into view. When you make an image generation, you cannot necessarily see the process, but that's how it works. Here's a video I generated to give you an idea of how a diffuser actually makes an image when you run an image generation. It starts off with noise, it gets spotty, eventually this kind of comes into view, and now you've got the full picture. In the context of language, DLLMs, diffusion language models, can actually generate multiple lines of text all at the same time and then iterate on them until eventually it comes to the final response. Inception's Mercury LLM supposedly can generate 1,000 tokens per second on an H100, which is unheard of. Now, in the original research papers that I found about these, it said that it had a lot of overhead on the GPU usage because it took a lot of inference time compute. But I think what Mercury did was nailed it down, so these are actually more efficient than autoregressive models. I wonder if this is the kind of thing that's going to overtake chain of thought with autoregressive models, or if this is the kind of thing that would fade away and people forget about it quickly. I really don't think there's any in between because this is so drastically different. There are also some challenges because it has not been thoroughly tested on long form text and multi-turn conversation. We also don't know if these are going to really overall perform as well as autoregressive LLMs and what other kind of shortcomings they could have because this is a very new technology. I noticed neither of those examples showed the actual diffusion process, and it was like a simulation and it was masked in some way. So I'm going to look into it to see if we can see the entire process unfiltered. There's no way to actually watch the diffusion process, but they do have a page on their GitHub that explains their inference methods and their supervised fine-tuning. So you can read through that and there's some technical details. There's also a paper on Arxiv about their diffusion language model technology, and you can read through that as well. But that wraps it up for today. I just wanted to give a brief overview of how these diffusion language models are different than autoregressive next token prediction and actually work similar to image generation. If you're new to my channel, I like to test open source AI models, and I also make video tutorials about Linux for running your own AI programs. If that interests you, please hit the subscribe button. I hope to see you in the next video. Take care of yourself and have a good one.